Hi everyone, I'm Sandhya, Department of Mathematics. Today we are going to discuss about the self-reciprocal for the Fourier transform. So in the self-reciprocal, if the Fourier transform of f of x is equal to capital F of S, then f of x is said to be a reciprocal function under the Fourier transform. Okay, so that is what is that? Capital F of small f of x is equal to capital F of S. In the question is instead of f of x we replace e power minus x square by 2. So we have to prove that e power minus s square by 2. Okay, so show that the function, so see the question, so that the function e power minus x square by 2 is self-reciprocal under the Fourier transform. So the final answer is e power minus s square by 2. That is the self-reciprocal. Okay, so here first we see what is f of x. Okay, so here the f of x is 1 by root 2 pi minus infinity to infinity e power minus s square by 2 into e power isx into dx. In this exponential is common, so adding e power, so here also minus x square by 2, that is minus x square by 2 isx, okay, into dx. Next we have to taking the minus x by 2 is outside, so minus x by 2 1, that is what is that, minus 1, that is e power minus 1 by 2 x square minus 2 isx into dx. Here it is a formula for a square minus 2ab. Here we missing the b square. Okay, so in this b square is nothing but is, so adding and subtracting the is the whole square into dx. Okay, so this is the formula for e power minus x minus is the whole square divided by 2, that is a minus b the whole square by 2 plus e power isx into dx. Okay, so here see, so this is the a minus b the whole square formula, so the remaining one is e power isx the whole square into dx. Okay, next step. So after that, the integral is based only upon the x. Okay, so in this e power isx divided by 2 is constant, take it outside. Next we have to use the substitution method, t equal to x minus is by 2. So instead of t we replace minus t, so here also the t square. Then we want to substitute dx is root, that is root 2 dt. Okay, so here we replace. Okay, so the answer is root 2 divided by root 2 pi e power minus s square by 2 minus infinity to infinity e power minus t square into dt. So next e power, that is e power minus infinity to infinity e power minus t square, that is e power minus x square into dx is nothing but root pi. So here we replace root pi, so root 2 get cancelled, so the remaining one pi is there, so 1 by root 2. Okay, so here root pi get cancelled, so the answer is e power minus s square by 2. So the e power minus x square by 2 under the, we applying the Fourier transform, we get e power minus x square by 2. This is the self reciprocal. Okay, next here also we see, yeah, one this is the self reciprocal under the Fourier transform. So here once again we see in this self reciprocal, if the Fourier transform of f of x is equal to the capital F of x. Okay, so then f of x is said to be the self reciprocal under the Fourier transform. So here wait, e power minus x square by 2 of in the Fourier, we giving the Fourier transform, it is replaced by e power minus x square by 2. Okay, so this is the self reciprocal. Okay, next it is the Fourier Percival identity. In this Fourier Percival identity, let f of s be given Fourier transform of f of x, then minus infinity to infinity minus that is the modulus f of x the whole square into dx is equal to minus infinity to infinity modulus capital F of s the whole square into ds. This is the Percival identity. So what is the purpose we use the Percival identity? We have to use the higher order, we have using the Percival identity. So the Percival identity formula is minus infinity to infinity modulus f of x the whole square into dx is equal to minus infinity to infinity modulus f of s the whole square into ds. Okay, so in this class we saw what is Percival identity and what is self-reciprocal under the Fourier transform. So e power minus x square by 2 is self-reciprocal under e power minus x square by 2. Thank you.